So welcome back again. Today we are going to discuss the third problem of today's contest, which is apply operations to make two strings equal. So in this problem you are given two binary strings s1 and s2, both of length n, and we have to make two strings equal. And we can perform some operations to make them equal. In the first operation we can choose two different index I and j and flip both characters s1 of I and s1 of j. Now the cost of applying this operation is x. In the second operation we can choose two adjacent element of s1 and flip both of the adjacent characters, and the cost of applying this operation is 1. Now we have to determine whether it is possible to make the both strings equal, or if it is possible then we have to determine the minimum cost needed to make strings s1 and s2 equal. So let us see how we can approach. So this is the test case, and so the first operation is to choose two different index I and j, and we will choose those index we are different, because if we choose the index which are already same then it will eventually gonna increase our cost. So I and j will be index where they are differing, and after applying the first operation it will increase our cost by x. Now in the second operation we can perform operation on two adjacent elements and have a cost of 1. Now in the test case we are having indexes where they are differing are 0, 3, 5 and 8. Now the string from 0 to 3 is in s1, which is 110, and in s2 it is 010. So 3 will be from 0 to 4, 1100 and 0101. So it is differing at two index, at 0 this place and this place. So let us see what is the number of operations you will require to make two strings equal by applying the operation of type 2. So we know that the first character is differing in both strings, so we have to apply the operation on the starting index. So this will be, the s1 will be changed to 0 0 0 0 because we apply operation on this character. Now this index, the second index, has also differed, so we have to apply operation on second index, so it will become 0 1 1 0. Now starting two characters are equal but the third character is differing, so we have to apply operation on third character, so it will become 0 1 0 1. So now both strings are equal and we have performed operation on the three index, which is starting index minus ending index. So number of operations is nothing but last index minus starting index. So second operations is nothing but if we have to change, or if we have to make a string equal where it is differing at I and j, so the operation is nothing but j minus I, where j is the last element where it is differing and I is the starting element it is differing. So we will erase this. So we have another form of the second operation, which is if there are two index where the string is differing, so we can perform operations j minus I times from starting to j minus 1 to make them equal. We have seen here. So we have to make 0 3 5 8 equal in both strings. So at every step we have two choices to perform, either to perform the first operation or to perform the second operation. Now see that if we perform the first operation, we will be moving forward to next one, and we will include our answer, or we will increase our answer by x if we are performing the first operation. But in the first operation, we have to choose two different index. We have only choose the first index. So in future we can also choose another index apart from this, and when we'll choose this index, it should have a cost of 0 because we have already included a cost of x. So we will be declaring another variable, let us suppose count, which will be denoting the number of operations of type 1 we have performed. Initially it was 0 when we haven't performed any operations of type 1, and when we'll be performing operation of type 1, we will be incrementing the count. So we have performed operation of type 1 on the first index, and we have included our answer and increased the answer by x. So in future we can also perform we can select the jth index of the first operation. We have choose the ith index of first operation, so jth character can be chosen in future. So this count will be showing that which is the jth character which can be chosen. And when we will be incrementing for the first operation, we will be incrementing our I by 1. So now when we will be having I pointing to the first index, now here also we have two operations to perform. Either we can perform operation of type 1. If we perform operation of type 1, there is no need to increase our answer by x, because we will see whether count is non-zero or not. If count is non-zero, then there is no need to increase our answer by x, because we have already included our answer as x. So we can directly move to the next character, and I will be pointing to here. Now when we are moving forward after applying the operation, we should remove or decrease the value of count, because now a pair of I and j has been found and we have increased our answer by x, right? Now when I will be pointing to this character or this number, if suppose we have to perform the operation of type 2, then performing operation of type 2 is nothing but the difference between the I plus 1th value and ith value. So here if we perform operation of type 2, then answer will be incremented by v of j or v of I plus 1 minus v of I, and I will be incremented by 2 here, because we have already find the jth or I plus 1 pair, because operation of type 2 is applied on a pair of adjacent elements only. So we have find the adjacent element and we have included our answer. So for the second operation, I should be incremented by 2, but for the first operation I should be incremented by 1 only, because we can apply operation of the first type by choosing I, and jth can be chosen anywhere. We have to focus on this count, whether if count is 1, then we have already chosen our ith number for the first operation, and we have to choose the jth number for the first operation. So if we go likewise, this will lead us to TLE, because the time complexity will be in exponential. So what we can do, we can make a DP array which will be storing at the ith character. If suppose we have count number of operations which we have performed of type 1, what will be our answer? It will be saying, and these repetitions will be minimized by this dp vector, because we are storing and memoizing the table, and when we will be at this position in future, then dp of I count will directly return the answer in O of 1, so the complexity will be reduced to O of n square. Let us see the implementation. I have declared a vector d which will be storing the number of index or the index value where the string are differing, and we will be pushing in the vector. Now if it is of odd size, we can't perform any operation to make them equal, because at every operation we are choosing two distinct element, right? So there is no way to think that we can perform operation on odd vector size. Okay, so we will be declaring a dp vector of size 500, and then this is vector d, this is the current pointer x, and n is the number where it will be denoting the number of operations we have performed of type 1. Now initially raise will be maximum, and we can perform operation of type 2 whenever it is at second last element. So if I is at second last element, we can perform operation of type 2. So it will include the answer of d of I plus 1 minus d of I, as we have discussed, and increment the pointer to I plus 2, as we have discussed, and raise will be, we can perform operation of type 1 and increment the counter by 1. And see, this is the count variable I was discussing here, which will be denoting the number of operations of type 1 we have performed. So when we will perform operation of type 1, the counter will be increased by 1 and cost will be increased by x. Now if we have performed operations of type 1 earlier, then no need to add any cost. So we are not adding any cost, because we have performed operation of type 1 and we have chosen the jth value, ith value, and we are choosing the jth pair of the first operation as this index, and we will decrement our count variable, and at last we will be storing this in a dp vector and return it. So this is the accepted code. So if you like this video, you can give a thumbs up and subscribe to my channel. Thank you so much.